Hello everyone. Today we will calculate electric field into dipole at equatorial point. Equatorial point is a point on the perpendicular bisector of dipole. Dipole is a combination of plus q and minus q charges separated by 2. Okay. So that point I have taken P where I have to find the net electric field due to both charges plus and minus q. So from our fundamental knowledge, whenever there is a single plus charge, electric field is always outward. Always remember. If there is a minus charge due to a single minus charge, electric field is inward. This is the fundamental basic knowledge we should have. Okay. So first I will calculate field at this point P due to A. So let me join these two this charge with point P because I am interested to find the field. Okay. So at this point, field due to A, what will be the formula? The basic formula of electric field due to any charge is kq by distance square, right? So what is the distance? If this is 2A, so this distance will be A. The distance of the point P is always taken from the center of dipole. So suppose that point is at a distance of x. So what is the distance between point P and Q? Because we are interested to find field at P due to Q. So this distance, if you apply the Pythagoras, what will it become? It will be under root of a square plus x square, right? You can apply the Pythagoras in this triangle. This is 90 degree. Okay, you can see. And this is the diagonal. So AP will be root of a square plus x square. Let me write it. AQ. D is root of a square plus x square whole square. So what it will become? This will become KQ by, let me write it here only. KQ by a square plus x square. Right? This under root will disappear because of this square. Now we should know what is the direction. See here. Due to this plus charge, direction is always on the joining line away from the charge. It has to be on the joining line. Remember, it can't be anywhere else. On the joining line away from the charge. So this is the charge. Away from the charge is this direction. Let me call this direction. We can call it. So this direction is nothing but PF. Correct? Now, what is electric field at P? What is electric field at P? Due to B, we have to calculate. Okay? So here, it will be, if I join these two, this is the distance because I want to know field at P due to B. So it will be KQ by D square. And what is the distance? This is again A and this is X. So what will be this distance? This will be exactly same if I apply Pythagoras. So let me write down here. Let me change it. So this will be root of x square plus a square. So field will be KQ by root of a square plus x square whole square. Okay. So this will be KQ by a square plus x square. Why? Because see, this will cancel. Under root and a square will cancel. Okay. So let me show the direction of this. So this is the minus charge. So due to minus charge, it will be towards the charge. So I got two fields, EPA and EPB. The magnitude seems to be equal. Can you see? KQ by a square plus x square. It is KQ by a square plus x square. Magnitude of these two fields are same, but directions are different. One is in PN direction and one is in P. And they both are vector fields. Okay. So at point P, I got two electric fields. One electric field is due to A, which is this. One electric field due to B, which is this. But I need net electric field. I am interested to find E net. So how to calculate net electric field? So when two fields of two vectors are at some angle. So there is a method to solve it. We change both of the vectors in vertical and horizontal components, and we see if they are in opposite directions, we subtract. If they are in same direction, we add. Okay. So in order to find the net electric field, we will convert them into two factors, horizontal and vertical. Let me show you how. So for E net, what we will do? We will convert both force, both electric field, EPN and EPB, in vertical and horizontal components. Correct? We will convert it into two components. So let me take Pn first. If you have any vector in this direction, and say F or E, if you have to convert into two parts, how do we do it? If this angle is theta, always remember, wherever there is a theta, we write that side cos theta, and the other component becomes sin theta. That's how we break vector into two parts. Okay? Suppose there is a vector which is in this direction. Suppose this is a vector and I want to break it into two parts. Suppose this is theta and I want one horizontal component and one vertical component. So wherever there is theta, that side I take cos. So this side will be E cos theta and this side will be E sin theta. Okay. Let's take one more example. Suppose this is some vector E and I want to break it again in two parts. Okay. But I know these two angles now. This angle. I know this angle. Instead of this angle, I know this angle. So remember, wherever we have theta, that side goes cos theta. Okay. This we would have learned in 11th class. So I'm just revising it for you. So which side is theta? That side is cos theta. Other side is E sin. That is how we break any vector into two components. Okay. So here I will break EPN into two parts. So you can say this is my EPN. Can I break it into parts? This is my horizontal part and this is my vertical. Let me show you in these two. Let me use green color for EPN. So this is horizontal, this is vertical. And I am taking this angle as theta. Okay. So by geometry, if you see, if I extend these two lines, observe carefully. And this is the cutting line. See, these two are parallel. This is cutting line. So if this angle is theta, so this will also be theta. And observe here carefully. See here, if these two lines are parallel and this is cutting. So if this angle is theta, this will also be theta. Okay. So by that law, I am using, if this is theta, this is theta. Okay. Okay. So EPN will have two components. So this component will be EPN cos theta because this side is the angle. And this component will be EPN sin theta. Okay. This is vertical component upward and this is horizontal. So I have divided it into two parts. Correct. Now let me divide EPB into two parts. This one. So I will be using blue color to show you here, guys. So this is EPB, right? This was the direction of EPB. It can be divided into two parts. EPB. What? Cos or sine? What should I use? See, if this is theta, suppose this is theta. Listen carefully. If this is theta, so this will also be theta, right? Like if you watch carefully, these two lines are parallel. See, these two are parallel and this is cutting line, correct? So what will happen? If this is theta, this will also be theta, right? You have to be carefully see. If this is theta, this will also be theta by this law. If there are two perpendicular lines and one is transversal line, then alternate angles are equal. If this is theta, this is theta. Okay? And when you are breaking this into two parts, this EPB I am breaking into horizontal and vertical. So this will be EPB cos theta. Why cos theta? Because which side is theta? That side becomes cos theta. And the other side becomes sin theta. So let me write down. This will be EPB sine theta. Understood? I hope. So I have broken both of the parts into two parts. So you see, this is vertical and this is vertical and they are opposite. Can you see? EPN sine theta and EPB sine theta. They must be equal and opposite. Why? Because we remember are equal. Why they are equal? Because we remember that formula of EPN and EPB was what? KQ by x square by a square. They both were equal. So that means EPN sine theta and EPB sine theta will also be equal. Correct? So they will be equal and they are opposite. So what will happen? They will cancel each other. Correct? So we don't need to worry about vertical components. There will be only two horizontal components. Now what to do? So vertical components were there and they are equal and opposite. They cancel each other. Now we have to take care of the horizontal components. So there are two components, EPN cos theta and EPB cos theta. So what should we do? If they are on opposite directions, we cancel, means we subtract them. If they are in the same direction, we usually add them. Correct? So what will be the horizontal components? They will be added. Why added? Because they are in the same direction. You can see this is also here, this is also here. So E net will be nothing but EPN cos theta plus EPB cos theta. Now we will put the values. EPN was KQ by x square plus a square cos theta. And what was EPB? We derived it already. Right? It was KQ by x square plus square cos theta. Perfect. Now these two are same things. If you look at it, KQ cos theta by x square plus a square, watch it carefully. KQ cos theta by x square plus a square, they are the same thing. So what can we do? We can add these two. So 2 KQ cos theta by x square plus a square. Now we should know what is cos theta. That is our problem. What is cos theta? It's pretty simple. Look at this triangle. Look at this triangle. Let me highlight it. This triangle. This one. A, P, let me call this maybe T. This triangle. Triangle A, P, T. In this triangle, what will be cos theta? Let me draw it separately. If I draw separately for you, for better understanding how to calculate cos theta. So this is theta, this is A, this is X, and this is A square plus X square. So what will be cos theta? From this triangle we can take up. Cos theta is base by hypotenuse. That's how we do. It will be A by A square plus X square under root because it is base by hypotenuse. Yes or no? So what should we do now? We got cos theta. What should we do now to calculate cos E net? So E net will be 2KQ by x square plus a square, A by a square plus x square under root. Yes? I am putting cos theta value here. That's it. We got our E net. We just need to a little bit simplify it. And how to simplify it? See here. Can I write K into 2AQ? See, the numerator I am just rearranging K, 2AQ, writing together by x square plus a square power 1 and this is x square plus a square power half. Yes, under root means power half. And when they are same base, powers will be what? Added or subtracted. Base is same. X square plus. When we have the same base, so they will be added. So E net will be, write down, K 2AQ by x square plus a square power 3 by 2. Why? Because powers are added. No, 1 plus half is nothing but 3 by 2. Okay. What is 2AQ? Anybody remembers? So 2AQ is nothing but P, which is also known as dipole moment. That is how it is defined. Remember that dipole moment is the product of Q charge with the distance of 2, which is 2AQ. 2AQ is nothing but dipole moment. It's a vector quantity. So E net will be K into P by x square plus a square P by 2. What else can we do? Can we simplify it more? Right? We usually need a very compact formula. Can we make it further compact? Yes. The thing is, in dipoles, always remember, usually A is very, very less than X. The distance between two charges, this A or 2A, you can say 2A, is very, very less than X, the distance X. So can I say X is also less than X? So can I ignore, if A is very tiny, so A square will also be very tiny. So can I just ignore A square? We can ignore it. So E net will be Kp by x square power 3 by 2, because this I have ignored. So this and this will cancel. So E net will be Kp by x. So this is the net electric field at equatorial point due to time. Okay. So if we want to make the graph of E for dipole at equatorial point with respect to x, it dips very fast. It goes like this. It decreases very fast. Okay. So from here we can write a conclusion. This is at the equatorial point. Remember, it is half of the electric field what we get at axial. If you see the other video, their E nav at axial point was K 2P by X cube. Okay. So you can watch it in my other video. So this is very important derivation. You do it 2-3 times by yourself. Bye everyone. See you in next video.